Okay, thank you. So the name of this talk is an exciting intro to JavaScript unit testing. And this is a very challenging topic, but I'm going to try my best to make it exciting for you. Especially if you are a beginner, I think you will enjoy it. So I'm Juan Lizarazo. I'm a software engineer at Partner Software. I'm also a published instructor at udemy.com. And I do a lot of side things, but one of the things I do is I am a contributor to the AMP project over here. So if you see this blue logo, check the website. I'm going to show you here because this talk is not about AMP. Even though I'm always talking about AMP, but not today. Today is going to be the exception. So still check out the project. I think you will like it. So back to this, the topic. So the class I have on Udemy is unit testing your JavaScript with Jasmine. But today, I'm not going to really talk about Jasmine. This is just unit testing JavaScript. That's the topic I want to pass on to you. So the thing with this is like when we created, I created this with a friend, and when we created this content, I mean, it's challenging. How do you teach such complicated topic to beginners, and then you start this journey, and it's very difficult. You have to learn content delivery. You have to learn how to engage with the audience. And we learned a lot of lessons along the way. And even after publishing a year later, we get the feedback from the students. And that has given me some lessons that I want to share with you today. So if you're starting your journey, it's going to make it a little bit easier for you. So back to the topic. One more thing. I'm going to give like some free coupons to enroll on this towards the end of the talk. So stick around. So an exciting intro to JavaScript unit testing. Back to the topic. So let's start to see what Wikipedia says about it, because we need to know the definition. So unit testing is a software testing method by which individual oh my goodness, this is so frustrating. It's really boring that I'm just going to skip the slide. Because this is the issue here. How do we make unit testing exciting? That long definition, that's not exciting, and that's not going to help you. I mean, I don't even know that definition. I don't even understand it. I cannot even finish reading it. And well, in part because I'm not a native speaker, as you may notice. But this is the thing. Let's face it, unit testing is boring. I mean, like, even myself, I find it boring, and I teach it online. But, I mean, that's what it is. But this is the amazing thing about this topic, that when you're learning something, it doesn't have to be boring. So no matter the topic you learn, learning it doesn't have to be boring. And that's kind of like what changes things, changes the perspective. So let's start again. Let's try this again, but no more Wikipedia this time. What is unit testing? So let's look at a more friendly definition, a definition of mine for this. So it's just testing individual units of code. Your units, they could be a class, they could be a function, they could be a variable, they could be a whole module, or even your entire application. This is the thing. You define the unit. My recommendation, don't go too small. I mean, don't test variables. I mean, that you're never going to finish unit testing your code. So to refine this definition, let's add a little bit more of this. Let's define the unit. So usually, unit, in general, is the smallest testable part. But don't go with the variable. My recommendation, go with the function, or go with the class. I mean, you define the unit. I mean, not too big, not too small. Function is a good start. So let's keep that in mind. But this is the thing. Why do we want to talk about unit testing? I mean, you're not going to just get out of this talk and go start unit testing because Juan says that is exciting or that you should do it. Let's see real reasons of why you should learn this as part of our introduction. So the first thing is that you trust changes that you make on existing, already tested code. This just means that when you go to a project and you make a little tiny change, you run your unit test, or your test in general, and then if they all pass, you're confident that you didn't break anything because the code is already tested. This could be a manual process too. You make the change, you go test everything, and 2 hours later, you find you didn't break anything and you celebrate. But this is the thing. You don't want to spend 2 hours doing that every time you make a change. So it really helps you trust those changes. When you have a good unit test, don't worry about the coverage. Just unit test. Okay. Second one, why you should do it? Code quality, because the best code you have is the best code, is the code that you can unit test. Crappy code, you can't really unit test or test that at all. I mean, if you have looked at your old code from 10 years ago and you try to test that or automate it, I mean, good luck. I don't think you can do it. I cannot do it with my own code from 10 years ago. Because that's the thing, once you start unit testing, you will find that the quality of your code is better. It increases. It makes you a better engineer. The other thing is that today, if we work at startups, code changes occur quickly. They are happening every day. Things are changing fast. We are embracing this agile environment, even though I don't even know what that is yet. I'm trying to figure out if my next job maybe or my current job, we're gonna find out what this agile thing is. But the thing is about agile is things change quickly, right? Requirements are coming in. We have to make changes. And because of those changes, you have to keep up. You cannot be testing 2 hours every time you make a change. So unit testing will help you. So then those changes that occur quickly, you'll be confident that they're not breaking anything. Another benefit is that it documents your own code. When you have unit tests around your code, you're going to find, and we're going to see that in a little bit, that it helps you document your own code. You don't have to be writing comments. So don't write comments on a function that, let's say, is called get tweet, and then you put a comment saying it gets the tweet. I mean, you don't do that. Don't do comments on your code. The unit test will help you document your code. A big benefit of this is that when other team members are coming onto your project, they can just look at the unit test of those functions, those classes, and see how they are consumed. Because ideally, they will use using just the public API of that. So that will really self-document for your team. We had you making effort in documenting the code or putting comments everywhere. So it really helps. That's a very good one. And the last one, and my favorite one, automation. Because instead of spending 2 hours running, 2,000 cases manually, you're doing all the tests manually and all the stuff or on your code, you can just basically automate and run 2,000 use cases, test cases in 2 seconds. So who doesn't want that? I mean, I want to make a change, know in 2 seconds if I broke anything, and then move on to the next change. Build confidence. So that's really why. Now to the question, how do we unit test JavaScript? Because this is what we're here for, right? I mean, so far it sounds beautiful, everything I'm telling you, but we're here to talk JavaScript. This is a JavaScript conference, so let's get to that. So, as I was mentioning before, in the journey of becoming an instructor and delivering content for all these students all over the world and getting feedback from them, questions from them, I have learned some lessons about this. So I'm going to share 4, I call them core principles, lessons, you can call it whatever you want, that they will help you understand unit testing better if you haven't done it before, and if you have done it, it will help you comprehend or even teach your teams or mentor others about it. So these are 4 principles I'm going to share here, and let's explore the first one. This is a very important one. First, we want to pick a library or framework, and the reason is because when you pick an existing library or framework, on day 1, you have the work of hundreds of engineers that have been working on this for the last 5 or 10 years, and you get all that on day 1. So all you have to do is write your test. Really simple. And this is the thing. I have all these logos here. It doesn't matter what framework or library you got to pick. I'm not going to tell you, hey, you have to do Jasmine because I teach Jasmine. No. You have to pick the one that makes sense for your specific situation. And by that I mean your company or your project, you have a specific technology stack. And when this comes into play, you don't want to just say, oh, I want to force Jest into this other project, even though it's not going to work, I'm going to fight it. No, don't fight technology. Don't fight your technology stack. Pick the framework or library that makes sense for you. Don't try to build it from scratch. Yeah, it's fun. You can do it in a day, build something. It's not going to be so robust. You learn the things under the hood, how this thing works, but don't do that for production. Just pick the work, rely on the work of others. They're there to help you. So just pick one, whatever makes sense for your situation, for your tech stack. As long as you do it, you'll be safe and you'll be fine. The second principle is very important because, we pick the framework, and now what? Learn some core concepts. So we're going to explore some core concepts that you need to know, and they are common among different frameworks and libraries. And they apply testing principles, and I mean, you understand them, you'll be able to pick whatever technology you want and just go with it. But you'll understand it. So let's see what these ones are. Let's start with the first one. I like to start with the smallest one and then start building out. So the first one that we're going to explore here is expectations. So you probably have heard that, like, my expectations are not passing, or I'm expecting this. An expectation, you are expecting something out of something. In this case, we're expecting something out of our code. So the objective of these expectations is to test the state of the code. That's all you want with an expectation. So really simple so far. Okay, this is starting to make sense. We have expectations. They test the state of our code. But, okay, Juan, show some JavaScript. Okay, I'm going to go there, but because I'm not talking about a specific framework, this is generic, but you're going to notice that it's going to apply to most libraries and frameworks. I mean, whatever you pick, maybe some things switch, but it's very, very similar. So looking at the code for an expectation, we see here an example, expect 1 plus 1 to be 2. So the expectation here is that first function. We have a function, it's called expect, and we pass here, and in this case, an expression. It's evaluating to 2. But this expression could be anything. Could be a function call, could be an object, could be a class, could be a function itself. It could be whatever. As long as it is something that evaluates into a value, you pass it there. And our expectation is defined by this method over here, the expect. That's our function, defines our expectation. That's the first core concept that we need to know. The second one is going to be matchers. So matchers, a matcher is also a function, just like the expectation. Okay, so they're just functions. I mean, we're invoking them, we're passing something to them. We don't have to, it depends on the function. And the sweet thing of matchers is that they implement a Boolean comparison. So this just really means when you invoke your matcher, it's either going to be true or it's either going to be false. And that's it. There's no other way, true or false. Really simple. And the reason for this is because this is going to define if our test passes or not. And I'm going to talk a little bit more about that. So let's look at the code now. Again, same example. Expect 1 plus 1 to be 2. In this case, we're chaining a function. So chaining, I'm just adding that method with a dot to whatever expect 1 plus 1 returns. And this is our matcher. So this is going to complete our assertion. And this is going to return the Boolean comparison. True or false? False, the test is going to fail. True, the test is going to pass. Really simple. Now let's move on to the next core concept here. The next one is specs. So this one is, I would say, it's the most important concept here because this is what we want to put our effort into understanding because this is what we're going to be writing the most and working on the most in our time. So first, let's define this. So a spec is just a short of a specification. So a specification is just a behavior that is expected by some piece of software. So for example, I mean, we're talking about behavior-driven development. So for example, in my previous little snippet of code, I am expecting that 1 plus 1 is 2 in that case. That's my specification, Juan. If you sum 1 plus 1, it has to be 2. That's the requirement, that's the business need. So specs help us define that. Because that, if you understand the concept, when you are writing your test, you're not going to write something that like, oh, was this crazy method invoked? No, you're going to test like if the actual business result, the things you care about, was actually happening if the specification is met. So let's build on that because specs is complicated. So they help us group expectations. Remember, expectations test the state of the code. And this is very important because as you have a growing application, you don't want to put in a single file 1,000 expectations together because when one fails, the whole thing is going to fail. And you need to know what failed. So it's very important to group them. So specs help us with that. But maybe you say, hey, I haven't heard that spec. I mean, I thought you were going to talk about tests. Yes, Spec is usually exchanged with test. It depends on the library you use. It depends on the methodology you apply. If you're doing behavior-driven development, usually you're going to talk about a spec. If you're using Angular, you're going to talk about a spec. But in other frameworks and libraries, they are called test. I just treat them as they're exchangeable. So your test, group, expectations. Now things are coming together. But let's see these in the code, like how these specs look like. So let's look at this. Here I have a function. So test is also a function. So far the three concepts that we have seen so far, they're functions. So expectations, matches are functions, and tests are functions. It has a string, in this case, it's a description. So this description helps us document our code. It's self-documenting because in this case, if you see in the spec, I'm calling a method called sum, and I'm doing 1, 1. So it's 2 arguments. Something is happening inside of it. I don't care what happens. I just know that it has to be 2. That's my expectation. And I could have more expectations in there. I could do more tests, put in that test maybe sum 2 plus 2 and 2, then 3 and 3, and expect it to be 4, and expect it to be 9, 6, it doesn't matter. So that's up to you. You can group them. So now you have a logical way to group the expected behavior, because these are still expectations, for your application. So if you have a module, and it has a class, and then you expect that class to do something, then you're going to have a set of different tests for that. But that's, it might be confusing, but here, like you identify, like if you see this, you say, hey, this is a spec. Okay, now I know it. And this applies for most of the frameworks and libraries out there. They're very, very similar. But sometimes in other frameworks or libraries, you will see that is exchanged by this word, it. It's the same thing. The difference is like if we read the previous one says here, let's see. So this one says test. If we read test adds 1 plus 1 to equal 2, when you read it, doesn't sound as good. So someone decided at some point to call it it. So then you read it like it adds 1 plus 1 to equal 2. Self-documenting, and it makes sense to read to an English speaker. But that's the function we're invoking. So far, this is good. But we have one more core concept here. Because imagine that we have a ton of specs everywhere, a ton of tests. We need to group them somehow. We need some organization, especially for large-scale applications, where you have a lot of files, a lot of modules, a lot of things going on. You have to organize your tests as well. So we have a way, a mechanism to group them, and this is also the same thing. It applies to most frameworks. This is a core concept here, which is suites. So suites, they help us group tests, and they help us organize our units. So when you think about our units, okay, remember that concept of the smallest piece that is testable? Like, you define that unit. So for example, you can start with a suite, and that suite can define that you're testing a service. And then you have another suite inside of it, and you decide that that suite is testing or is describing the behavior for a specific method in that service. Then you're getting organization. And when you do error reporting, when you get reports out of these, it's really nice because you can see when something fails. It tells you like, oh, this one is failing. So it points it to the behavior. And it also helps with the self-documenting part at the organization, because then you have a logical way of group your code. So in this case, we have the describe. And this is the way you do it usually in the frameworks or in the libraries. So you do describe. In this case, I'm going to describe the behavior of that method that I had previously put there, which is sum. And in this one, it also receives a callback. So this arrow function over here that we have on the right, that one could be exchanged with function. And then you put all your specs. So I could put a lot of it calls, a lot of them inside of that. And I could test that maybe handles. Maybe I can do, it handles negative numbers. It handles when I say undefined. Different test cases that are handled. And inside of that, I can have the different expectations that when they evaluate to true, the test will pass. So this is very important because remember that our matcher helps us get the Boolean comparison. When we have that Boolean comparison, if we have at least one of them is false, the whole spec is going to fail. So you're going to have a failing spec. So just remember that. Failing spec, when your test fails because it returns, some of the expectations return false. At least one. Just one, it will fail the whole spec. So that's why grouping is important, because then you'll know, oh, it fell for this function. I didn't touch that function, but maybe you have a side effect. Maybe you change something else that affected that function. So that's really good. Then, in this case, this is how you identify the suite. It's describing the behavior. So in this case, I'm describing how some should behave, and that's a suite. Okay, so now the next one, and the next one is very important. And there's some controversy about it, so I'm not going to get into that, but from what I've learned from experience and teaching people, this one makes total sense, at least for beginners, and I think for advanced experienced engineers that are testing. And this one is, do not test implementation details. You don't want to do that. So seriously, ever, don't do it. Like, I seriously mean it. And I'm doing emphasis on this because this is very important, especially with JavaScript. Like in JavaScript, we don't really have this concept, these access modifiers where we can do private natively. So usually it's like, oh yeah, I can access all the private functions in my class because there's no such thing as private. I can do that. So don't test implementation details. And the reason for this is because if you start testing implementation details, if you start testing your private functions, you are not going to be able to refactor. So when you get to refactor, refactor, when you have to make big changes in the code because you have to support other use cases, you have to optimize it, the refactoring is going to be really hard because you're going to probably not refactor your code. You're going to end up refactoring your test. And we don't want that. We don't want to spend all this time refactoring test. If you just don't test implementation details, this is going to work really well. And by implementation details, I'm going to put an example here. So it makes more sense. So in this case, for example, back to our code, we have our test that we previously saw, just adds 1 plus 2 to equal 3. And we have our expectation there. Spec sum, the invocation, to be 3. If you look underneath, that's an imaginary definition of that method that I have there. And I have some comments there of what that could look like. I mean, it could be it returns B plus A, or A plus B, or it doesn't matter. It could be that it returns number, and I parse it because maybe I'm receiving a string, and I pass a base of 10, and then I do my operation there, or it could be anything else. So when I talk about implementation details, and this is a hard one when you're starting out, don't think about testing every single line inside a function, or if you're calling private functions, or you have private things that it shouldn't be exposed or are not part of the public API, what you want your consumers to use, probably other engineers, it doesn't matter. You treat that as a black box. You just know that you have your inputs for some, in this case is A and B, and the signature of this is going to return the sum of those two numbers. That's all you care about. So that's why our test accomplishes this. I don't care what happens inside, if there's binary operations, it doesn't matter. I mean, this is a very simple example, but just imagine the power of these words here. That if you don't test implementation details, the day I come and I optimize my sum function so it can run 10 times faster, I mean, I don't think that's possible, but if I were to do that, I wouldn't care for updating the test. I'm not going to be refactoring the test. And when I make my refactor, my change, we're going to know that everything is still passing, meaning that I can deploy to production right away and nothing is going to break because all the tests pass in this case. And that's our core, our 4 core concept here, our third. So now let's go to the 4 core concept, which is actually, I mean, it's not going to be mocking or stubbing. I'm not going to get into that. Or, hey, let's isolate dependencies because I personally, I mean, yes, I'm talking about unit testing. But as I said, I define my units as bigger pieces of code. So then I don't have to be into implementation details and I don't have to be doing so much mocking anymore. So the 4th one is not going to be that. I'm not going to talk about mocking or stubbing, isolating dependencies so everything is perfect and controlled because that's not how your software runs in real life. So the 4th one actually is write test. You have to get your hands dirty, write test, fail at it, and embrace failure because failing tests are going to make you a better engineer because you're gonna know that you broke something right away and then you're gonna fix it before you ship it. Your customers are gonna love you for that. So write tests. Okay, so let's do a recap of this. So first, pick a library or framework, rely on the work of others. Second, learn some core concepts. Remember, expectation, test or spec, and the matcher, and the suite, or the function that is called describe. With those four, you can learn any testing library right now out there, and you'll be just fine. You'll just get it. And the third one, do not test implementation details. I cannot stress this enough, but just don't do it. And the fourth one, write tests. I mean, it's the only way that you can become better at it, and, well, it's going to make you a better engineer. You're going to build better, more robust software. So before I forget, I promised you tickets to enrolling for free. I just have 10. Sorry about that, but you can use the Utah.js 2019 code. I'm going to share the slides today, so you can take the picture of the last slide. There's a link there, and you'll find it after this session. I will publish them, and you'll see a link to the class if you're interested in enrolling for free. You don't have to pay for it. Okay, so if you got that, I just want to finish this by saying that don't fight the technology stack. Pick the correct solution for what you're doing, because remember that technology is our friend. You don't have to fight it. If you're fighting it, you're doing it wrong. Just think about it. If you're doing something and you're fighting it, and it's just supposed to work, maybe it's not like that you're using it. It's probably that you're using it wrong. You shouldn't force things. Just don't do it, because technology is our friend. It's here to help us and make our lives easier. Thank you.